So far we have discussed the following contents under the heading of sawing. First one is various methods of sawing like hand sawing and power sawing, and next we classify various power sawing machines and discussed about the working principle of various power sawing machines like horizontal sawing machine, vertical sawing machine, band sawing machine, etc. Next we have discussed about saw setting and various types like straight set, raker set, wavy set and its nomenclature. Now we discuss various types of saw blades. Generally these three types of saw blades are used. One is standard tooth form, another one is skip or buttress tooth form, another one is hook or claw tooth form. Standard tooth form blade type of blade is mostly used. It produces accurate cuts on fine finished surface. The tooth has 0 rake angle, 30 degrees back clearance angle and deep gullet. It is the standard tooth form blade. It is the skip or buttress tooth form blade. The tooth has 0 degrees rake angle and back clearance of 30 degrees. Teeth are spaced wider apart to provide greater chip clearance. It is recommended for thick work sections, deep cuts and soft material. It is the claw or hook tooth form blade. It has a positive rake angle. It cuts at faster rate and at reduced feed pressure. Cut materials like structural forms and pipes. Now we discuss about the specifications of hacksaw blade. In order to purchase a blade, we fully mention the specifications of the blade, the following specifications of the blade. One is length of the blade, next one is width of the blade, and next one is thickness of the blade, and next one is number of teeth per cm, that is called pitch of the blade. Next we discuss the specifications of power saw. In order to purchase a machine that need to be specified with the following parameters: diameter of bar stock it can cut, length of the blade that the machine can accommodate, length of stroke, number of strokes per minute, capacity of the motor, type of drive. Next we discuss about various applications of hacksaw. Hacksaw blades are made with specified pitch. The selection of pitch depends on the hardness, the shape and thickness of the material to be cut. In general, the blade with coarse pitch is adopted for cutting soft material, while the blade with fine pitch is used for harder materials. When cutting thin sections, at least 2 teeth, preferably 3 teeth, should always be in contact with the workpiece. Therefore, blades with fine pitches are recommended for thinner sections which are not suitable with coarse blades. The applications of hacksaw blades are given on the following table. If the blade with 12 teeth per cm, it is called fine pitch blade. It can be used to cut material up to 3 mm thickness. This is used for the following applications: thin sheets and tubes, hard and soft materials of thin sections. A blade with 9 teeth per centimeter, it is called fine pitch blade. It is used to cut material up to 3 to 6 mm. 3 to 6 mm. This is used for the application of cutting thicker sheets and tubes, hard and soft materials of thicker sections. A blade with 7 teeth per cm, it is also called fine pitch blade. It is used to cut material from 6 mm to 12.7 mm. It is used for the application of cutting heavier section of ferrous and non-ferrous materials. A blade with 5 teeth per cm is a coarse pitch blade. It is used to cut material about 12.7 mm. It is used for soft materials of heavy sections. We discussed already that when cutting thin sections, at least 2 teeth should always be in contact with the workpiece. It is already discussed that when cutting thin sections, at least 2 teeth, preferably 3, should always be in contact with the workpiece. We take some of the applications about the right way of using blades. Here, for cutting a round rod, coarse teeth blade is used. It gives enough chip clearance. It is the right method. If we use fine pitch blade, small chip clearance, there is a provision to clog the teeth. Here, for cutting tubes, fine pitch tooth is used. It is the right method because 2 or 3 teeth are in contact with the work. If we use coarse teeth blade, there is a chance to strip out. We will see some other applications. Here, fine blade is used. It is correct method. Here, if we use coarse blade, there is a chance to strip out. In this application, this is the right method because more than 2 teeth are in contact with the work. This is the wrong method. So far, we have discussed the following contents under the heading of sawing. First one is various methods of sawing like hand sawing and power sawing, and next we classify various power sawing machines and discussed about the working principle of various power sawing machines like horizontal sawing machine, vertical sawing machine, band sawing machine, etc. Next, we have discussed about saw setting and various types like straight set, raker set, wavy set and its nomenclature, and various types of saw blades like standard tooth form, buttress or skip tooth form and claw or hook tooth form. And next, we have discussed about specifications of hacksaw blade and specifications of power sawing machine. Finally, we have discussed various applications of sawing. Hello students, in this session of program, we are going to discuss about the topic broaching. Now, I am introducing What is broaching? Broaching is a secondary machining operation like shaping, planing, milling, etc., but not like these machining operations in which the tool having a series of cutting teeth called broach is either pulled or pushed by the broaching machine past the surface of workpiece. In doing so, each tooth of the tool takes a small cut through the metal surface. Under the heading of broaching, the following subtopics are going to be discussed. Under the heading of broaching, I am going to discuss the following contents: introduction, principle of broaching, classification of broaching, broaching tool, nomenclature of broaching tooth, classification of brooches, broaching materials, types of broaching machines, working of various broaching machines, applications of broaching, advantages of broaching, disadvantages of broaching, broaching machine specifications. Now, let us discuss about what is broaching. Broaching is a method of removing metal by a tool that has successively higher cutting edges in a fixed path. It is shown schematically in the figure. Each tooth removes a predetermined amount of material. Here the tool reciprocates similar to sawing operation. In sawing operation, tool moves to and fro several times, whereas broaching operation is completed in a single pass. Now we discuss about principle of broaching. In broaching, the broach is pushed or pulled over external flat surface of a stationary workpiece. In internal broaching, the broach is pushed or pulled through the hole in the stationary workpiece. In certain machines, the broach is held stationary and the workpiece translates over the broach. For each successive tooth is a little higher than the one preceding it. Therefore, each tooth removes a layer of work material. First few teeth on the broach are low to permit the small end of the tool to be passed through the work. The machining operation completes in one pass of the broach. The cutting action of broach is shown with the following figures. It is surface broaching figure, it is internal broaching of a hole, it is continuous broaching. We discuss about them later. The material removal using the broach teeth is shown schematically. Here the dotted line indicates the amount of material being removed by the successive individual teeth. Now we discuss on the classification of broaching. Broaching is classified according to method of operation as follows. First one is pull broaching, push broaching, surface broaching and continuous broaching. Pull broaching, work is stationary, broach is pulled to the work as shown in figure. Next one is push broach. Here work is stationary, broach is pushed to the work. Next one is surface broaching. The broach moves across the work or vice versa. Next one is continuous broaching. The work is moved continuously against stationary broach broach is stationary, table revolves with workpieces. Now let us discuss about broaching tool. A broach is a multiple edges cutting tool that has successively higher cutting edges along the length of the tool. A broach has generally three types of teeth. They are roughing teeth, semi-finished teeth, finished teeth. It is shown in the diagram: roughing teeth, semi-finishing teeth, finishing teeth. The first roughing tooth is the smallest tooth on broach. These are designed to cut heaviest metal. The next portion has semi-finished teeth, which are progressively increased in size up to and including first finishing tooth. Finishing tooth are designed for lighter cuts. Last few finishing teeth are made of same size to attain high degree of accuracy and surface finish. Pull end is designed to permit engagement of the broach with the broaching machine by using puller head. This is the pull end. Front pilot, this is front pilot, keeps the broach in the center of the hole before cutting. Rear pilot, it is the rear pilot, and follower rest, this is the follower rest, support the broach after the last tooth leaves the hole. A push broach is made short in length to prevent bending under compressive load. Now let us discuss nomenclature of broach tooth. The nomenclature of broach teeth is as shown in figure. The height of teeth gradually increases from shank to finishing teeth. This increment is called cut per tooth. It varies from 0.01 to 0.2 mm. Its variation depends on the work material and size of the hole. The pitch is defined as linear distance between the cutting edge of the tooth and the corresponding edge of the next tooth. The pitch selected should be such that at least 2 or 3 teeth must remain in contact with the job. The pitch is calculated by using the following formula, empirical formula: P equal to 1.75 square root L, where L is length of the job to be machined in mm. An average pitch for small broach is 3.2 mm to 6.4 mm. For long broach is 12.7 mm to 25 mm. Land is the top portion of the tool, land, it is the land, top portion of the tool, and is ground to provide a slight clearance. Clearance angle, it is the clearance angle. Too small clearance angle causes rubbing of teeth against the broached surface. Its value varies from 0.5 to 2 degrees. Rake angle corresponds to rake angle of lathe tool. It depends on the work material. Its value increases as the ductility of increases. Mild steel is the ductile material. For that it is 15 to 20 degrees. For alloy steels it is 6 to 10 degrees. For cast iron it is 4 to 8 degrees. For aluminum the rake angle should be as high as possible. Gullet, this provides space for the chips to curl and escape. This is the gullet. If the space is not sufficient, the chips will rub against the whole surface and spoil it. It is the correct chip formation. This is incorrect chip formation. Here design of gullet is not correct. Now let us classify brooches. Brooches are classified as follows: according to type of operation, according to method of operation, according to type of construction, according to the operation they are classified. According to type of operation, brooches are classified as follows: internal brooch, external brooch. Internal brooch, for enlarging the existing hole to a desired form. Internal brooches are used for enlarging the existing hole to a desired form. External brooches are used for machining the external surfaces to desired form. According to method of operation, they are classified as push type brooch and pull type brooch. Push type brooch is pushed through the work while broaching. Generally, internal brooches are push type. Pull type brooch is pulled through the work while broaching. Generally, external brooches are pull type. Now, let us shift our discussion on type of brooches are classified on type of construction. According to type of construction, they are classified as solid brooches, built up brooches, inserted tooth brooches. Solid brooch is made in single piece, but built up brooch is made up of several sections. Inserted tooth brooches have series of teeth of increasing size are inserted in a block of steel. They are made like that. Another one is progressive cut brooch. The part of teeth of progressive cut brooch are same height along its length, but have different width as shown in figure. According to the operation, they are classified as hole brooch, surface brooch, keyway brooch, spline brooch. This is the keyway brooch, this is the spline brooch, this is the hole brooch, this is the surface brooch. Now we continue our discussion on broaching materials. High speed steel having the composition of 0.7% carbon, 18% tungsten, 4% chromium and 1% vanadium is the most suitable material for brooch. It is hardened before teeth are ground to required finish. Some brooches have inserted carbide cutting edges braced on the body of the brooch. It is mostly used in the broaching of cast iron. Now we discuss about various types of broaching machines. Broaching machines are classified as follows: horizontal machines, vertical machines, special design machines. Horizontal machines may be pull or push type. Vertical machines may be pull up, pull down, push down. Horizontal machines are further classified according to type of drive and according to type of operation. According to type of drive, they may be classified as mechanically operated, hydraulically operated. According to type of operation, they may be classified as surface broaching machine, internal broaching machine. If we come to vertical machines, according to type of operation, they may be classified as surface broaching machines, internal broaching machines. Special design machines are classified as follows: rotary table continuous machines, horizontal continuous machines. Now we discuss about horizontal broaching machine. The horizontal broaching machine is used for surface broaching or internal broaching. Generally, most commonly these machines are used for surface broaching. In surface broaching, the tool is pulled over the surface. The work is held in the fixture. For internal broaching, the broach is pulled through the work, that is through the hole. These machines are mostly pull type and can be operated at a cutting speed of 3 to 15 meter per minute. The horizontal surface broaching machine is shown in figure. The broach is pulled over the top surface of the workpiece held in a fixture. Now we discuss about vertical broaching machine. It is also used for surface broaching or internal broaching. It is most commonly used for surface broaching. It has a vertical slide to which the broach is attached. The workpiece is held in a fixture on the table. The broach tool is pulled vertically down against the stationary workpiece. Vertical broaching machines may be of the push down, pull down or pull up types, but the majority of machines are pull type. Now let us discuss about push down broaching machine. The principle of push down broaching machine is shown in figure. The holes previously drilled, punched or cored may be finished accurately. It requires sharp broach of sufficient cross section to prevent bending due to force imposed during the operation. Now we discuss on pull down broaching. Pull down machines are used for internal broaching. The principle of internal broaching on these machines is shown in figure. The workpiece is placed in a fixture on the table and the pulling mechanism is housed in the base of the machine. In operation, the broach is pulled through a hole. After completing the operation, the broach is moved up to the initial position. In this machine, the positioning of the part is easier and large parts are handled easily. Next, we discuss about pull-up broaching. The pull-up broaching machines are used for internal broaching for small parts. The principle of operation is similar to pull-down machines, but it is reversed. Next, we discuss about duplex head broaching machine. This broaching machine has two slides. Those two slides are called duplex heads. Hence it is called duplex head broaching machine. These are mostly push type machines and are commonly employed for surface broaching. The rate of production with these machines is high. Now we discuss about continuous broaching machines or special broaching machines. In continuous broaching machines, the broach is held stationary while the work pieces are continuously passed under them. In these machines, the workpieces are loaded and unloaded without stopping the machine. This facilitates continuous operation. These machines are used for mass production of small components. Continuous broaching machines are classified as follows: rotatable continuous broaching machines, horizontal continuous broaching machines. Now we discuss about those machines one by one. First one is rotatable continuous broaching machine. In this machine, the workpieces are fixed on a revolving table under a stationary broach. This type of machine is used for facing of small parts. This is the broach, stationary broach. Workpieces are fixed on the revolving table. It is the revolving table. Next one is horizontal continuous broaching machine. In this machine, the work is held in the fixture which are mounted on an endless chain. The chain carries the work in a straight path under the stationary broaches as shown in figure. It is used for surface broaching.
Further clarification, contact the Additional Secretary, State Board of Technical Education and Training, 7th floor, BRKR Bhavan, Tank Bund Road, Hyderabad 500063. Fax 040 322 0546.